mean. This is section 5.2. We finished section 5.1, and this is the second section about trigonometric functions. And we will talk today, we will define the 6 trigonometric functions of an acute angle theta. So we will define today the 6 trigonometric functions of an acute angle theta. That's why they call it right triangle trigonometry, because we will consider only right triangles. This is a right triangle, okay, and this is the angle theta, and as you can see, the angle theta is acute angle, and remember that acute angle means less than 90. In a right triangle, we have a right angle which measures 90 degrees, and we have 2 other angles. Their measure together is another 90 degrees. So the sum of the 3 angles of any triangle is 180 degrees. This side is opposite to the angle theta, so we call it the opposite side. This side is adjacent to the angle theta, so we call it the adjacent side. This side is the hypotenuse of the right triangle because it is opposite to the right angle, so it is called the hypotenuse. So we need to define the 6 trigonometric functions. We will define sine theta to be A over C, the opposite side over the hypotenuse, while cosine theta would be the adjacent side B over the hypotenuse, and tan theta would be the opposite over the adjacent A over B. Now cosecant theta, and remember that cosecant theta is the reciprocal of sine theta. So sine theta is A over C, cosecant theta is C over A. Secant theta is the reciprocal of cosine theta. So cosine theta is B over C, and secant is C over B. Cotan theta is the reciprocal of tan theta. So tan theta is A over B, cotan theta is B over A. So you need to understand this and memorize these definitions. You will be given a right triangle like this, and you will be given A, B, C, for example, and he will ask you to find the 6 trigonometric functions of theta. So these angles, sine, cosine, tan, secant, cosecant, cotan, are called the 6 trigonometric functions of the acute angle theta. Remember here, we deal only with acute angles in this section. So all angles in this section are between 0 and 90 degrees. Great question. Is there a way to help me remembering these definitions? And the answer is yes, there is a word, this word, SOH CAH TOA, SOH CAH TOA, or SOH CAH TOA, okay? S from sine, OH opposite over hypotenuse, C cosine, AH adjacent over hypotenuse, T for tangent, OA opposite over adjacent. So this is the word that will remind you that sine is the opposite over hypotenuse, cosine is the adjacent over hypotenuse, tangent is the opposite over the adjacent. Now, sine theta, for example, sine this angle, sine theta, depends only on the angle theta, on the size of the angle theta, not on the size of the sides. So if this is 3 and this is 2, sine theta would be always opposite. Sorry, tan theta, for example. Let us talk about tan theta. And it is true for sine, for cosine, for all the 6 trigonometric functions. Tan theta opposite over adjacent 3 over 2. You can see that in these 4 triangles, theta is the same. But the measure of the sides are different. This is 2, 3, this is 4, 6, this is 1, 1.5, 3, 4.5. But if you divide the opposite over the adjacent, you will get always the same result. All right. Remember the Pythagorean theorem. The Pythagorean theorem says if you have a right triangle and C is the hypotenuse, and this is A and this is B, then A square plus B square equals C square. The two legs, the sum of the square of the two legs equals the square of the hypotenuse. This is the Pythagorean theorem, and we will be using it to find one of these 3 sides. So he will give me 2 sides, and I will use the Pythagorean theorem to find the length of the 3rd side. First example, find the value of each of the 6 trigonometric functions of theta in this figure. What do we have? We have the opposite side to theta and the adjacent. So I immediately can find tan theta. Tan theta is the opposite over the adjacent, so it is 5 over 12. And immediately I can find cotan theta, because cotan theta is the reciprocal of tan theta. So it would be 12 over 5. Okay, now to find sine and cosine, I need to find the hypotenuse, which is C. So how can I find C? I use the Pythagorean theorem. We know that 5 square A square plus B square equals C square. So from here, you can use the calculator and find C square. It would be 169. So taking the square root, C would be positive or negative square root of 169, which is 13. But C, as a length of side, it cannot be negative. So we take the positive number only. So C is 13. Once I have C, I can find sine theta. Sine theta, opposite over hypotenuse, 5 over 13. And once you find sine theta, you can talk about cosecant theta, which is the reciprocal of sine theta. The last one is cosine theta. Cosine theta is the adjacent of theta, which is 12 over the hypotenuse, which is 13. The reciprocal of cosine theta is secant theta, and it is 13 over 12. So this is the answer of the question. Similarly, you can solve this exercise. Please do it at home. Also, similarly, you can find the value of the 6 trigonometric functions are here in this figure. You can find the length of this side using the Pythagorean theorem, and then write the 6 trigonometric functions, and here is the answer. Remember, we rationalize the denominator. If you have a square root in the denominator, square root of 2, for example, if you multiply by square root of 2 over square root of 2, then square root of 2 times square root of 2 is 2, and 1 times square root of 2 is square root of 2. So we will need to rationalize the denominators here in this section. Let us solve this example. Find the value of each of the 6 trigonometric functions of theta in this figure. And now C is given, but B is not known. So what do we have? This is the angle theta, okay? We have the side opposite to theta, and we have the hypotenuse. Which function I can find? What is the function that opposite over hypotenuse? Yes, correct. It is sine theta. So sine theta is 1 over 3. What is the reciprocal of sine theta? Yes, it is cosecant theta, which is 3 over 1. Now to find tan or cosine, I need the adjacent side. How to find the length of the adjacent side? I use the Pythagorean theorem. A square, 1 square, plus b square equals c square. So b square would be equal to 9 minus 1. So it is 8. So b would be plus or minus square root of 8, but b is length, so I cannot take it negative, so we take the positive. So it's the square root of 8. If you simplify square root of 8, 8 is 2 times 4, so it would be square root of 2 times square root of 4, and the square root of 4 is 2, so square root of 8 is 2 times square root of 2. So now I can find cosine theta, for example. Cosine theta is the adjacent, which is 2 square root of 2 over the hypotenuse. Now, the reciprocal of cosine is secant theta, and it is 3 over 2 square root of 2. Now, I have a square root of 2 in the denominator. I need to rationalize the denominator, so I multiply by square root of 2 over square root of 2. I get in the numerator 3 times square root of 2, and in the denominator, I have 2 times 2, because square root of 2 times square root of 2 will give you 2. 2 times 2 is 4, so that's the answer. This is secant theta. Finally, I can find tan theta. Tan theta is the opposite side, which is 1, over the adjacent side, which is 2 square roots of 2. I need to rationalize the denominator, so I multiply by square root of 2 over square root of 2. I get square root of 2 over 2 times 2, 4. And finally, cotan theta would be the reciprocal of tan. Tan is 1 over 2 square root of 2, so cotan would be 2 square root of 2 over 1, or just 2 times square root of 2. Similarly, you can solve this exercise, find b first, and then find the 6 trigonometric functions of theta. Also, you can find the length of this side first, and then find the value of the 6 trigonometric functions of theta. And here are the answers. Let us solve question 7 from in the book. Now let us assume that this side is A. Let us call it A, okay? Usually, if this angle is capital A, the length of the side opposite to theta is small a, and the length of the side opposite to capital B is small b, and 35 is small c. Well, what do we have? This is the angle theta. The opposite side is not known. This is the adjacent side, which is 21. And the side opposite to C, which is the right angle, is the hypotenuse. If you know the adjacent and the hypotenuse, what can you find? I can find cosine theta, because cosine is the adjacent over the hypotenuse. If you find cosine, immediately you can find the reciprocal, which is secant theta. It would be 35 over 21. Now to find sine and tan, I need to find A. I find A using the Pythagorean theorem. I know that A square plus B square, which is 21 square, equals C square, which is 35 square. So A square would be 35 square minus 21 square. 35 square is 1, 2, 2, 5, and 21 square is 441. So a square would be 1225 minus 441. It would be 784. I asked the calculator to find the root of 784, and I will get that A is positive or negative 28, but we cannot take the negative because it is the length of side. So A is 28, so the opposite side is 28. So I can find sine theta, which is the opposite, over the hypotenuse. And the reciprocal of sine is cosecant theta, which is the hypotenuse over the opposite side. And finally, tan theta, which is the opposite over the adjacent. And cotan theta is the reciprocal of tan, and it is the adjacent over the opposite. Now, objective 2. Let us continue with the definition and find the values, the function values for some special angles. And if you have seen the previous section, you must know that our special angles are 30 degrees, which is pi over 6, 45 degrees, which is pi over 4, 60 degrees, which is pi over 3. These three angles are the special angles. Now we will learn a method to evaluate the 6 trigonometric functions of these angles without having a calculator. You have to remember this triangle. This triangle, this is the angle 45, and because it's 45, so this angle is also 45. So if the length of this side is 1, this is also 1. And you can use Pythagorean theorem to find that the length of the hypotenuse in this case is square root of 2. So remember this triangle. The triangle of 45, 1 square root of 2 is the hypotenuse. From this triangle, you can find the 6 trigonometric functions of 45. So what is sine 45? Opposite over hypotenuse. If you multiply by square root of 2 times square root of 2, you will get square root of 2 over 2. And the reciprocal of sine is cosecant. So cosecant 45 is square root of 2, reciprocal of 1 over square root of 2. Now, cosine 45 is also the adjacent over the hypotenuse, so it is exactly equal to the sine because 1 and 1. And secant 45 is also square root of 2. So if you use the calculator, it will give you these answers. Tan 45 is opposite over adjacent, it is 1. And cotan 45 is the reciprocal, which is also 1. And this is the only acute angle. The only acute angle with tan equals 1. What about 30 and 60? For 30 and 60, we will use this triangle. Okay, 90, 30, 60. This is 30. It is less than 60. So if the opposite side of the length of the opposite side to 30 is 1, then the hypotenuse is 2. And we can use the Pythagorean theorem to find that the length of the opposite side to 60 is square root of 3. You can imagine that this is an equilateral triangle. So all the sides are equal. So this is 1 and this is 2. So all the sides are equal. So if you draw this line perpendicular, it will bisect this line. So we have 1, 1, and this is 2, and this is a square root of 3. Let us find the 6 trigonometric functions of 30. Now concentrate on 30. What is sine 30? Opposite, which is 1, over hypotenuse, which is 2. So what would be cosecant 30? It would be the reciprocal, which is 2. What about cosine 30. Cosine 30 adjacent, square root of 3 over 2, the hypotenuse. Now, secant 30, which is the reciprocal of cosine 30, is 2 over square root of 3. To rationalize the denominator, we multiply by square root of 3 over square root of 3, and we get 2 square root of 3 over 3. Tan 30 is the opposite, okay, opposite 1 time over the adjacent, which is square root of 3. Rationalize by multiplying by square root of 3 over square root of 3, you get square root of 3 over square root of 3. So cotan 30 would be the reciprocal of 1 over square root of 3, which is square root of 3 over 1. What about 60? Please use what you studied here and find the 6 trigonometric functions of 60 using this triangle. But remember, the opposite side to 60 would be square root of 3, and the adjacent side of 60 would be 1, while the hypotenuse is always fixed. If you memorize these two triangles, you will be able to find the 6 trigonometric functions of these special angles without using a calculator. And these are the exact values. We need the exact values. We don't accept approximations here. Okay, you have to say square root of 3. This is another way, if you want to memorize these trigonometric functions. You can write a table like this. You can start by the smallest, 30, then 45, then 60, and sine, then cosine, then tan. You can write a fraction like this, okay, for sine and cosine, and put always 2 in the denominator. So there is always 2 in the denominator. And then in the numerator, write 1, 2, 3, and put square roots. So this will give you sine of pi over 6, sine of 45, sine of 60. Remember that square root of 1 is 1. For cosine, you start by 3, 2, 1, not 1, 2, 3. For tan is easy. We will learn in a while that tan theta is actually sine theta over cosine theta. So don't worry about tan. Tan, you divide sine over cosine. To find tan, you divide sine over cosine, you get tan. So you need to memorize sine and cosine for these special angles. I'll stop here. It's okay to stop here, and I will open the floor for questions. Please, if you have any question, you are welcome to ask.